Welcome to Full Stack for Hackers. So this is more of a discussion on what it means to really be a full stack hacker. It originally started as a workshop for how to apply engineering concepts offensively, and then it became kind of a conversation around how a hacker can leverage a lot of development tools or engineering tools to do their job better, and vice versa. What a full stack engineer or any kind of engineer could use from a hacker's tool set to build better systems. So a quick introduction. My name is Christopher Forte, or I said no cookies. I'm a security researcher. I do a lot of software and infrastructure engineering. My background is in computer science or software development, but I've worked in various positions from software development to CTO to red teamer. So I've seen a lot of things and I've had a lot of experiences. And a lot of these slides or a lot of the topics that I'm going to discuss are things that I wish I was exposed to earlier or things that I would have thought about earlier in my career. So what is this all about? So a lot of it comes down to the conversation of like, what would a full stack development for hackers look like? A lot of times this conversation comes up with people who want to get into cybersecurity and say, what do I have to learn? Or how can I apply my development skills to getting into cybersecurity? But we have full stack developers, so are there such things as full stack hackers? Or is that kind of implied in the nature of the word hacker? But a lot of times, in my personal opinion, a good hacker is able to touch every layer within a development stack. So we're going to try to go through a lot of the layers and try to differentiate between how a hacker might approach a system versus how an engineer, what the tool sets look like, and how they kind of deviate as you progress through different topics. So I like to start out with defining some terms because a lot of these have some interesting connotations. So for example, when we talk about a hacker, I like to talk about an individual who solves technical problems, typically in non-traditional ways, or using tools non-traditionally. I like to be very careful with how we use the word hacker, because in the corporate world, or within a lot of enterprises, as soon as you say the word hacker, there's a malicious intent involved. And I think it's important to redefine that and just use hacker as a word for people who are solving technical problems, maybe in weird ways, or finding new ways to solve a problem that we hadn't previously thought of. When we talk about full stack developer, this also means a lot of different things to different people. It could just be someone who focuses on the front end and back end of an application. So deploying a front end, a GUI, some sort of HTML interface to a website, and then a back end service. But you could generalize this to someone who can deploy an entire system. So everything from infrastructure and networking all the way up through potentially managing the whole pipeline. When we talk about an engineer, it becomes a little bit more of a professional definition. So someone who invents, designs, analyzes, builds, tests stuff. And typically when you talk about an engineer building things, it's within the scope of cost or optimizations or working within the bounds of some sort of business objective. So it's important, at least within the context of this, is to kind of make this a more formal definition of an engineer, someone who's building something to be maintained over the period of its lifetime. When we talk about offensive, we're typically just talking about the adversarial perspective to cybersecurity or security in general. It's the opposite of defensive, and with the colors, it's usually the red side of things. And I also think it's very important to kind of define here that a lot of people will have different opinions of each of the layers within the stack, how the stack actually relates to cybersecurity, and there might be some unpopular opinions with how someone can get into security by leveraging specific subsets of the stack. But throughout this, you're going to see that there's a lot of different technologies that get discussed, and it's important to leverage that and say, yes, security is a team sport. We don't expect anyone to be an expert in everything. It's an unrealistic goal, but it's really nice to have an idea of how things come together so that when you either attack a system or you build it, you can have those things in the back of your mind. Okay, so when we talk about the full stack in the concept or in the context of this presentation, We start at the infrastructure, and we go all the way up through other. So we go infrastructure, networking, different types of data persistence or data storage, the application, some sort of virtualization or containerization. Then you start getting into things like automation, metrics, logging, security processes, and other topics that typically we may not normally address when we talk about like a software developer or even a hacker per se. But it's a pretty complicated stack. So at the top you have bare metal infrastructure all the way up through very cloud native stuff. Once you start with the infrastructure, usually your infrastructure has to communicate between itself. So that's either between different hosts or between different systems or even within itself on the same host. So we have our networking. Usually an application has to have some sort of persistent data. So we go to a data storage or a data persistence layer where we have our databases or even block storage. On top of all of that sits some sort of application that runs some sort of logic. And this can be very diverse, everything from serverless to compiled, interpreted, client-side, server-side, mobile applications, and this continues to grow. Video games, VR, AR, like this is a very diverse layer. And then you have your others, which is everything from security to monitoring, different SRE tools, compliance, account management, secret management, PKI. All of these things come together to build a single system. So when we talk about a full stack developer, typically we're just looking at the application layer. But when we start talking about how we attack a system, we may start to break this down and touch every single one of these layers. And typically when you look at every single one of these layers, there's a vulnerability involved, whether it's a misconfiguration or something that can go wrong to give an adversary a foothold or some way into your system or some way to abuse your data. So this stack is also growing and is by no means comprehensive. So we're going to go through these layers and kind of address it from both an attacker or an offensive standpoint, from like a cybersecurity standpoint, as well as from an engineer's perspective. So at the very bottom of our stack, we talk about like infrastructure or cloud. So either bare metal, cloud, you have things like hyper-converged infrastructure. Containers sometimes get sucked into this, but we'll push this to another layer kind of later on in the discussion. But it can be everything from a multi-billion-dollar infrastructure that hosts the public cloud to a Raspberry Pi. It's just something that hosts some sort of service and provides something to your system. Usually when we talk about this layer, we're talking about things like infrastructure engineers, site reliability engineers, depending on your organization. Even sometimes network engineers will touch this layer for having their hands on hardware. With the new age of the cloud, we'll call it, now we have cloud engineers, and they're the ones that are standing up a lot of the underlying infrastructure for cloud environments. And some of these I'll go through different roles that are addressed to it, because I do believe that cybersecurity is difficult to break into. It's an extremely complicated field. And I think each of these different layers can be a great way to break into security. So starting as an infrastructure engineer and migrating into security, or starting as a network engineer and migrating into security, application developer and into security. Because a lot of it shares the same underlying concepts, and both typically will rely on a deep understanding of the fundamental technology that you're touching. So when we talk about infrastructure in the scope of hackers or being offensive, it's not just attacking someone else's. Sometimes if you have this kind of knowledge of how to leverage it, you can have everything from your own labs, your own environments to attack other groups from. You can emulate attacks. So if you know you're going to be attacking someone in an Azure infrastructure or environment or an AWS, it's really good to know how that works so that you have some context or some knowledge of the underlying process. We're even going as far as when we talk about threat actors, talking about like cloud-aware threat actors, people who are using the cloud to their advantage and exploiting the feature sets of them to be more effective. So it's really important to start looking at these from both sides. From an engineer side, these are the types of attacks and vulnerabilities that you'll typically see. From an offensive side of things, or from an attacker standpoint, there's a lot of good things that can come from it. But typically we're looking at, from an attacker standpoint, like misconfigurations, unauthorized access. There's a lot of reuse of credentials that are leaked, account takeovers. In very rare cases, you're starting to look at like hypervisor escapes or breakouts, where you're attacking something and you're escaping to the underlying infrastructure. Shared tenancy issues. A lot of the cloud is shared tenancy. So someone else's application is hosted right next to yours, and if you can break out of that or migrate into someone else's, it gets usually bad. We've had some of these pop up. They're more rare, but they're obviously pretty devastating. Some denial of service attacks focus on the underlying infrastructure, which can be dangerous. Or hardware attacks. This is where the physical stuff sits. So if you can get access to the physical equipment, you can usually start to cause some problems. But it is important to just kind of notice that this is the underlying layer of most of our applications, or all of our applications. And a lot of the stuff that we touch can be very important to know, where the boundaries are between who you're attacking and the underlying infrastructure. So we even start to talk about things like, the shared responsibility model of cloud. If you're a pen tester, you need to know where to stop so that you're not breaching someone else's terms of service for attacking or their conditions. And it's good to have knowledge of these systems so that you can stop before you start breaking laws. But it's a great tool set. So you have your infrastructure, and then on top of your infrastructure sits some sort of communication layer. We're going with a generalized just networking. Your hosts have to talk to each other. Your network services or your services have to talk to each other. And this layer is becoming increasingly more complicated. So we have everything from actual hardware, where you're dealing with switches, routers, modems, whatever, all the way up through virtualized appliances, or things that get a little bit more complex, like mesh networks, or different tunneling technologies. But a lot of the questions that we ask ourselves are like, how do customers or users connect to us? How do we maybe connect to the application? Do we go through a load balancer? Is there some sort of layer between us and our system, like a firewall? From an offensive side, how do we get traffic out from a system that we may have compromised to another system? How do we prevent other systems from connecting to systems that shouldn't talk to each other? So there's a lot of questions here that can have a lot of implications for security. We're talking about a lot of like network, infra, and cloud engineers. A lot of them deal with the underlying infrastructure or the underlying network layer. This is another great place to get into cybersecurity, because this is one of the first attack vectors that you'll see traffic on. And it's one of the kind of sources of truth of indicators of compromise is the network. But it gets more and more complicated, and this is a great layer. There's a couple other slides where things that have historically been used for building things can be used to attack things, or used to manage your attack surfaces. So a lot of times we want to look at how we get access to segmented systems, and that could either be offensively or just for the sake of building a system. In the age of containers and virtualized systems, typically we'll have hosts on different networks, different physical networks that need to appear on the same network, or we need things to communicate internally. So some of those questions of how do we traverse networks kind of transparently for an application, start to pop up. But there's a lot of attacks and a lot of vulnerabilities that can be introduced just through the network. So things like man-in-the-middle attacks, unauthorized access, even through stuff like DHCP exhaustion. This is where a lot of things, if they stop talking to each other, a lot of systems will panic. So you have your denial of service attacks that you could potentially limit your bandwidth. Information disclosure, if you're not encrypting everything between systems, there's a lot of information that could be sent on the network. And then we start getting into some fun stuff, like how you exfil the data with bypassing different controls or monitoring processes. And this will even get into the wireless technologies. There's a lot of people running around with antennas, even maybe like sub-gigahertz or different technologies to communicate over wireless space. So networking gets continually more complicated, because when we look at it just plugging things into a LAN or having things talk to each other on private networks, like that's great. But we can go even further into like tunneling, port forwarding, for both sides. So it's an example of how an attacker may leverage tunneling to get into an internal system or to maintain access to an internal system. But tunneling isn't necessarily just used maliciously. Some developers use tunneling to expose internal systems without exposing IPs, or to tunnel between two systems like IPsec tunnels. So there's a lot of reasons why you may want to tunnel data constructively, and a lot of those tools, for better or for worse, can be used maliciously. So recently, it's been really interesting to go through some of the tools that are used for development and see how you could leverage that offensively, because a lot of these things are expected in an environment and don't raise a lot of the red flags, like you would see like a meterpreter port forwarding process running on a system, or SSH tunneling on some really weird port. So we start looking at things like Cloudflare tunnels or Argo tunnels, DNS tunnels. There's some fun processes that we've been playing with recently, like Nebula, which is a mesh network you can span across multiple hosts. So a lot of these things that are typically used in like Docker or Kubernetes, you can pull out and start to use maliciously. Maybe instead of an identifiable C2 network, you could use something that may blend in with an environment. Teleport or other solutions that allow you access to a system, and it's typically encrypted access, you can pull out and start using maliciously. And it starts to blend into an environment, which is great for attackers. So once you have your network, we'll kind of move on to the next layer, which we have as data storage or persistence. This is a big one to discuss because when we hear about a lot of breaches, it's databases being leaked or breached. But it really, it answers the question of like, where is the data? A lot of logic is stored in memory or within an application. It is what it is. It can be rebuilt really easily, but if you lose all your data, it's very problematic. So at this layer, we're talking about everything from databases, file systems, object stores, where you're backing things up, just generally, where is your data? And it can be across a cloud-native solution or kind of a platform-agnostic solution. So you could use something that could be hosted in all cloud environments versus, something very specific like an AWS RDS. But it gets fairly complicated. It brings up things like how long do you retain data? Where is it stored? Is it shared tenancy? Is it shared with other infrastructure? And we're looking at a lot of like database engineers. Unfortunately, a lot of people will manage databases who don't have a lot of database experience. So you start getting like infra engineers or cloud engineers because they're standing up the databases in clouds. But it's a great thing to understand for both sides. For an engineer, that's where you store your data. It can be heavily optimized with database clustering or within private networks. And it can be important to understand like the implications of how databases work. From an attacker standpoint, this is one of our best targets. We want to attack the database because that's where all the data is stored. But we can also use it constructively as attackers for storing our own data with things that we're exfilling, creating exploits for. Maybe we use them as knowledge bases. Databases are obviously really important. And the more customized you can have a database, which there's a lot of customization, rather than using like an off-the-shelf note-taking tool or something, you can do a lot with it. But from an attacker standpoint, like I said, it's a great target. You deal with the data leaks, the breaches, credential leaks, SQL injections. Some databases allow you to do privilege escalation. Ransomware typically will try to attack your persistent data or your data stores. Data integrity attacks, changing data without people knowing, which can be very dangerous. Manipulation of accounts, whether it's permission sets or credentials. This is a huge attack vector for us, and a lot of times we attack applications just to get to the underlying data. It's one of those topics that I wish I was exposed more to early, because when I started to try to build applications out of a computer science degree, I had no idea how to use a database, and I set it up continually wrong with a lot of vulnerabilities. And then as I started to get more into cybersecurity, I started attacking more databases and realizing this is a problem. So this is another one of those fields that I think from both sides, it's very important to understand. And it can be advantageous. So we have our data store. So we need some sort of logic to manipulate the data. So this is where kind of our application layer sits. And this is a really complicated layer. This could probably be its own discussion on the different type of applications, how they're attacked, how we use them from both sides of things. But it's the thing that does the stuff, right? So this is where your logic sits. And it can be everything from web applications, mobile, desktop, embedded systems, different libraries that get included in other people's applications. They could be graphical with a GUI. They can be CLI-based or just sit running in the background. They could be serverless. So this layer is quite diverse. And then not only are they're kind of presented in different ways, but they're written in different ways. They're written in compiled or interpreted languages. Maybe there's some hybrids. There's multiple languages in an application. They could be cross-platform, so they could be written in one language and then compiled to another for a different platform. There's a lot of ways that we interact with applications. Everything from REST to other, it could be a GUI. But a lot of times we want to ask ourselves from an attacker standpoint, what is the application doing? How does it work? And a lot of times when we attack an application, if we're doing it blindly and we don't understand how an application works, we're just setting ourselves up for failure. Or we're kind of on a dangerous path of attacking something that we don't understand. From both sides, this can be a really good topic, and this is a really good point because a lot of people will say as you get into cybersecurity, you need to learn how to code. You need to learn development. And I think there's some truth to that, but I think there's also different approaches you can take when you address like software development or programming. So from an offensive side, we learn how to program for a lot of reasons, for writing exploits, phishing content, exploits, malware. We're writing our own systems, our own C2 servers, our own tools to scan things, our own tools to manage stuff. It could just be scripting to make our lives easier or to set up our own infrastructure. It could be writing applications to attack ourselves for research and development. From the other side, from the constructive engineer side, we maybe look at applications a little differently because now we have to maintain them. We have to have them last longer than just an attack. And this can go into multiple different layers. You can have something kind of short and sweet, like a script, or you can have something very in-depth, like a full application. But from both sides, a fundamental understanding of how applications are built in programming languages can go a really long way. But I still think that these are a little different. I think, and this is one of those conversations that I've had with quite a few people, as they get into cybersecurity, they want to get into red teaming or pen testing. I want to learn how to code. And what does that actually mean? Do you have to go through system design? Do you have to go through all of these processes to get into cybersecurity? And I think there's a little bit of deviation between how a hacker addresses software development or programming and how an engineer might. Engineers deal with maintainability. You have multiple people working on a code base. You may have different modules that have to talk to each other. But you're developing for optimization and for it to scale. You start getting into weird things that hackers don't think of, like coding style, at least at some level. The more you get into writing code, the more it could kind of, they merge a little bit. But you start getting into compliance. How does your code look? What are you using it for? Is it a regulated industry that wants a specific standard of C, or do you have to do certain things a certain way? How is it audited? Are you using consistent technology stacks across the organization so that you're not have very segmented development teams? You start getting into like well-known paradigms for development or how systems look. And a lot of this stuff hackers don't really care about. For a lot of stuff, hackers just want things to work. This is one of the reasons why I brought up the definition of hackers. It's just solving a solution in potentially a non-traditional way, and writing code is not an exception. Some of the code that we write is absolutely terrifying. If a developer were to look at it, it's just a disaster, but it works. And that's really all that matters to a lot of people who are attacking systems or writing exploits. It's quick to develop. A lot of hackers try to do stuff very quickly. There's a time element to it. You can't sit there and overly optimize an algorithm because you just want it done. So quick to develop. And a lot of times for an offensive position, it's environment dependent. When you're building a system for a company, sometimes you get to pick your technology stack, or you have to use something that your team's used to, or there's a lot of things that can go into picking what you're going to use. Someone on the offensive side may not care. They're just going to pick whatever they're comfortable in. Maybe it's Python. Maybe it's something that doesn't actually fit the bill, but you know it well enough where you can make it work for a small task. Hackers, or on the offensive side, we get into weird stuff like obfuscation or writing very confusing logic so people don't know what you're doing. Some engineers do use this to protect their IP or to prevent people from stealing something or reverse engineering it to write additional attacks, but it becomes a little bit different. You have to maintain obfuscation. You can't just obfuscate your code at its fundamental level because you have to maintain it. So hackers may go as far as de-optimizing code to make it more difficult for someone to defend against. Sometimes hackers care about portability, or a lot of times they care about portability. If you're attacking a system and you write some sort of code that requires a lot of underlying libraries, you could potentially be in a weird situation where as you try to deploy it on a system, a lot of those dependencies don't exist. So how do you wrap things up into neat packages so that it can run on a bunch of different systems or systems that are configured differently? And it's important to know that hackers in this context don't always have malicious intent. You could just be writing a script to do something to make your life easier as an engineer. So there's different ways to address software development from both sides. And I think it's important to realize that so that we don't send people down a huge rabbit hole that doesn't necessarily apply to their immediate goals. Programming languages is another topic. Engineers versus hackers can pick languages for much different or very different reasons. Sometimes engineers pick languages just based on the skill sets that are available to them. If you go into a company and they say, hey, we need to write this new program, and one person knows one language and everyone else knows another one, typically you're not going to pick the one that only one person knows. You're going to try to find some middle ground so that you can have as much collaboration between a team. It's not a lot of, there's not a huge learning curve for the majority of people. Paradigms can drive what languages are used. Different environments can dictate what languages you use. If you're going cloud native, that may dictate what language you're going to pick versus an embedded system or mobile. So there's a lot of things that go into why you may pick a programming language, and it starts to deviate between an engineer and a hacker. The hackers, a lot of times it's either dictated by their comfort in a language. Some people will use, we've seen in like Capture the Flags, people use C++ to write a script because that's what they knew, and it worked, and it's fantastic. So a lot of it's dictated by either your comfort, it's what you can do quickly, or the environment. If you're attacking a Windows environment, you're probably not going to use, Ruby. You're probably going to use something like C#, or you're going to find something that's native, like PowerShell, to write your scripts in. And it can depend on what you know is available. If you're attacking cloud infrastructure, you're probably going to use a language that underlying platform supports. Portability is another big reason why we may select a language. Go has been more popular because it gets packaged in a nice little self-dependent executable. And we've seen some really interesting things with like malware going into something like Go because you can just cross-compile and ship it. Bigger binaries, but a lot of times maybe that doesn't really matter to a hacker. And a lot of times we don't care if the application's safe. If it gets us to where we need to be initially, then we can ship it, which is not necessarily how an engineer is going to look at it. They want to make sure they're using type-safe languages, or they're being very careful about memory. And hackers will do that as well because we don't want to be found out. If we're on a network, we don't want systems to crash unnecessarily. But it becomes a little bit more of a side effect of the objective. Scripting is one of our biggest, I think it's probably one of our most useful tools from both sides. And we kind of put this at the application layers because unfortunately some people use these as applications. They go and they ship services that are completely run on scripting languages. But it's a really important skill for both engineers and hackers. It can be used to automate different things, so to automate attacks, create environments, run tests, solve challenges. Engineers will use them to deploy things. Hackers will also use them to deploy things in their own infrastructure or in other people's infrastructures. A lot of times when we use them, we try to go more modular so that we can reuse code. A hacker may not care about that. When we start looking at like Python scripts, for example, you'll see an engineer have modules that get imported. It's very well structured. It's meant to be maintained. It's meant to be used across different teams, ideally, where a hacker may just be a disaster. It's a single shot script. But I think both of these have its place, and I think it's important when you start looking at someone getting into this field, if all their goal is to be a red teamer, maybe it's not that important to learn about how to make your code super modular. At least, I mean, there's a huge benefit to it, but it may be more important to focus on different technologies rather than like, computer science paradigms and the more complicated stuff, optimizations. Web servers are another one that I kind of put in the application layer, and I call out specifically because I use these probably more than any other specific type of application, whether it's to serve content to myself across different infrastructures, to serve stuff to customers or people trying to gauge what I'm doing for like a proof of concept. They can be used for both good and evil. So file transfers to and from compromised hosts. It can be as simple as like a Python module that just spins up a web server. It can be as complicated as a full Node.js server that has all of the customization you need. This is another, I think it's another interesting layer because it really does deviate from an engineer to a hacker. One just needs one quickly, and one needs one to work potentially over a long period of time. And a lot of this is being hosted now in containers or in serverless environments. When we talk about containers, we talk about things like Docker, Podman, LXD. Those get orchestrated through things like Swarm, Kubernetes, Fargate, which is an orchestration tool for one of those technologies. We have serverless technologies, quote unquote serverless, like Lambda or GCP functions. OpenStack has serverless features. A lot of this is how do we separate our application from the underlying host. So we just want code, we just want it to run, and we just want it to work. We don't want to care about the resources. We want it to scale effectively. And we want it to be able to replicate across multiple environments potentially. From an attacker standpoint, these can be very useful to have very replicatable environments. We can use them to package up our own tools. A lot of people will put their own tools, their scanning tools, their vulnerability management tools in containers because all they have to do is spin it up. It doesn't matter what system or what type of system they're hosting it on. And engineers enjoy it for a lot of the same reasons. If you can wrap up an application in a container and ship it, we can run it on multiple platforms, we can host it on different operating systems, and we can start to decouple our application layer from our underlying infrastructure. From an attack standpoint or from a vulnerability standpoint, we get into like container escapes, how we move laterally through different containers that may have access to different data or different credentials. Abusing resources, can we spin up additional containers in an environment? Can we attack where the container images are stored, like registries or different repositories? Some containers have access unnecessarily to credentials for either credential disclosure or privilege escalation, or for lateral movement within an environment. There's a lot of misconfigurations at this layer. You start getting into some things like denial of service attacks, where you could bring down an entire cluster, depending on how the resource of the orchestration tool works. This is something that we use a lot of capture the flag events. we use these so that we can separate an environment per team. From an attack point of view, they're a great target. A lot of people are going to this direction. So a lot of people are using containers because of the convenience and because of how it looks within an environment. So it's really important for both sides to kind of understand how containers work and how we can use them ourselves. So we have all these layers, we have all these technologies, all these applications, very complicated tech stacks. The next question is, how do we automate this so that we can avoid some of the human error that goes into managing all of these technologies? From both sides, it can be extremely important. From an engineer side, a lot of vulnerabilities come from misconfigurations or human error. You click the wrong button, you open up a rule. Automation can help reduce that. Or if you make a mistake, you only make it once. You fix it in your automation and you redeploy, and in theory, that issue is gone. We start talking about tools like Terraform, Ansible, Chef, Pulumi, Jenkins, different CI/CD services, even just scripts. A lot of people just use scripts to deploy depending on the feature set of the underlying tool that they're trying to use. But a lot of it is just, how do we recreate the same environment over and over? How are we consistent? Or how do we deploy it across a dozen different hosts and have the same configuration for everything? And a lot of times this is a very self-documented process. If I have a tool or a service and I have it wrapped up in a container and it's built through an image, and I have maybe an Ansible script to go configure a service, that could act as my documentation, that could act as my inventory. And for an attacker who may use a container seldomly, so if I have a vulnerable service that I'm attacking or researching, or I have a tool that works at a specific version of Python or has these dependencies that may need to be fixed, if you can wrap it in a container, it's replicatable, it's repeatable over time. I can store that, and if I ever need it again, I just need to pull that image and run it. For developers, it's fantastic. A lot of times it removes that issue of it works on my computer. If it works on your computer in a container, there's a very good chance it's going to work on another computer in that container. So it can be very important for both sides. So from an offensive point of view, it can be also a great target. As people start to use more things like Jenkins or Ansible or Terraform, that is the entire blueprint to your environment. Sometimes people have credentials. It can be used great for piggybacking on SSH or knowing who has access to things. It can be used to help pivot because you have the services that are deployed through an infrastructure. Or offensive people can use it constructively to build out their own home labs, or to build a version of a home lab that they can continually deploy. So if you have one infrastructure and you want to deploy something to test a process or something, you can deploy it with automation. And then tomorrow you can redeploy a whole nother configuration to test. And you can go back and forth between the two if your automation is good enough. But a lot of times it makes your life easier for both sides. This is something that I wish I knew a long time ago getting into software development, which was to not click buttons and GUIs and configure things manually, but to write scripts and to use different automation platforms to do it for me. So we start getting into that other layer. So we have all of these different layers in our stack. And we start getting into things like metrics and loggings. A lot of things that we typically forget about until it's too late, or we don't put into our application until we absolutely need it. But metrics and for logging specifically, we can really use to debug our infrastructure. We can use it for optimizations. For people that are defending systems, we can use it to detect different issues or indications of compromise. Sometimes we can use it to drive better development on an engineering team. So if we see things that keep popping up, or we see issues in our logs, or we don't have enough logs in a specific area, that can be a great next step for development so that we can refine our processes. Data-driven anything is typically a really good way to go through each of the stacks, because we have a little bit more of a reasonable drive to spend our time on. But metrics and logging can also be a great target for people. Sometimes they're not as well secured, or they're off-site, they're a different infrastructure. They can leak a lot of sensitive information. A lot of PII ends up in logs. Application logs like to ship things that we don't expect. They can be used for alerting for both sides. Offensively, we can use it to alert if we have a hit on something that we've put out in the world, or we can learn more about what an application maybe has visibility into. We can use it for data exfiltration. There are things like log poisoning, where logs will optimize themselves, like Log4j, and a lot of big things pop up because it's very convenient for the developers, but also a great attack vector for attackers. Logging is something that I think a lot of people don't put as much effort into as long as we have them. Sometimes it's a compliance checkbox, but we can leverage them heavily on both sides. And then we get into security, which is typically bolted on top of everything. In a perfect world, this is built into each of the layers, and there's something kind of natively built into that layer. But unfortunately, it's kind of just tacked on at the end. Once we have all of our features, we focus on security. But we start talking about like our firewalls, our WAFs, our intrusion detection and prevention systems, antivirus, EDR, XDR. There's lots of different tools that sit at this layer. And it is important to note that a lot of these are way more effective if they're built into the application or they're built into each layer natively, and it's not something that you do after it's been shipped and in production. But this is another interesting one for both sides. For an engineer, sometimes it's really important to know what services or what technologies you're using because it can impact the service that you're trying to deploy. We've seen a lot of people push like web servers out. They don't realize that it needs different ports that the security team is blocking, or they're doing something that's triggering EDR, or it's deleting certain parts of their scripts or their applications. So from an engineer standpoint, this can be a really good topic to learn because it's going to potentially impact what you're building. From an offensive point of view, it's really good to know what they're using to protect their systems because it's something that you typically will have to bypass or leverage. So it could be a great solution for like privilege escalation. A lot of EDR runs as a privileged user. It could be used for pivoting, credential reuse, credential abuse. Some security tools will allow you to SSH or connect to people's computers for reasons. So if you can gain access to someone's account that has that kind of privilege, it can be devastating. Sometimes this will actually give us a requirement for our network as an attacker. So if we know that there's IPS or IDS, or there's some sort of something looking at your traffic, then we have to start getting into how we tunnel data that mitigates those issues or evades those controls, or how do we encrypt our traffic so that people can't see what we're doing or what we're exfilling. So the security layer is a really interesting one from both sides. And it's something that we typically will forget until it's too late. And then there's the other stuff. So we have kind of the fundamental layers of our stack, and then there's other things that we kind of tack on to different environments. And every layer that we've discussed, you could go into a much deeper conversation about, and there's different layers into that, different technologies, and there's continually developments to make it more complex or more optimized. But as we go, kind of competition leads to new and exciting stuff, and it's something that both sides should be aware of, either to make their applications more effective, more user-friendly, or from an attacker point, what we could leverage against people. Secret management's a big one. We're seeing secret management or identity management being attacked quite a bit. We've just seen Okta used maliciously to gain access to into other people's stuff. If you can compromise someone's secret management application, it's terrible. That's where all of your stuff is stored. That's where we handle all of our important stuff. Instead of hard coding things, we try to have something manage it for us, and that can be a great step, but it can also be a great target if it's done incorrectly. From From an attacker standpoint, you look at things like Ansible. There's a secret management tool. It can be used, you can brute force or attack it if you don't use proper passwords. So there's a lot of things that as we get into secret management as a layer, from both sides, there's implications that you have to be aware of. But when you manage your secret, it's not just for passwords. It could be for your CI/CD pipelines, how they pull credentials to access different systems or services, like your API keys. You have things like HashiCorp has Vault, Ansible has Vault. Even some of the Git platforms have secret management built into them so that you can stop hard coding your secrets in your scripts and you can pull it from the environment. Even AWS and all of the cloud platforms have some sort of secret management or API process, underlying process that allows them to connect to services that they're supposed to connect to. So you have like your metadata services for each of the cloud platforms that has credentials and API tokens. So this is a much bigger layer than a lot of people realize because it's a lot of times built into the underlying infrastructure. But it's also an important thing for both sides, both attackers and for engineers. Engineers need to know how to use it to externalize the important information that their application needs, and attackers should know what the other side is using so they can either attack it or they can use it to hide their own secrets from people. PKI is another big one. This is becoming, at least personally, a bigger issue for a lot of people because this can be kind of what systems are protected with. It's kind of secret management, but it a little bit more complicated. HashiCorp Vault does have some PKI features built in, and all the cloud platforms have their own PKI. But managing your own certificate authority can be great for not only developers, either testing to have their own certs or to deploy applications, but attackers can use it as well. So attackers can have their own PKI to protect their own traffic. They can be used for proxies, manipulating a system's trust if you can get a system to trust your CA. There's certificate theft. If you can steal a private key for an underlying cert, a lot of times it has some very interesting implications. Developers use this quite extensively now. You'll see things like code signing or integrity checks, different cryptographic signatures on things that are shipped. And these can be very important to kind of maintain the integrity when you ship an application to a customer. Firmware uses this a lot. They have signed firmware so that you can't mess with it and then deploy a malicious version of it. But managing and understanding how certificate authorities work can be very helpful. From an attacker, you can potentially see why a man-in-the-middle attack won't work or why it will work. If you have things like cert pinning. And something as an engineer should be aware of is how you can prevent an attacker from getting in between your traffic or decrypting your traffic. Another thing that a lot of people don't talk about when you're going through like computer science or you're going through coding boot camps is things like obfuscation or reverse engineering. Both sides use this for different reasons. So why would you want to obfuscate software? If you're doing it from an engineer's perspective, there could be a lot of very legitimate reasons. It's not just malware. You could be trying to protect your IP. Maybe you can't protect a certain algorithm through a patent or through some other way, so you have to obfuscate it so that people can't reverse it. Cheating prevention is another really big reason why people will obfuscate their code bases. So game developers, this is something that they look at a lot. And there's a lot of cool things that come out of games that prevent cheating through things like obfuscation or cheating detection algorithms. Compressing files is another reason why you may quote-unquote obfuscate code. We see things like minified.js, which is some form of obfuscation. If I give you minified.js, it can be very difficult to read, and the underlying logic can be very difficult to get back. There are tools to do that, depending on how you obfuscate it, but it can be a great tool. From an attacker standpoint, we will obfuscate things to bypass or evade antivirus, or sometimes we just don't want people to know what we're doing. And it can be either to protect your code from other threat actors to use it and to create their own malware, or it can be to obfuscate your code to prevent defenders from being able to protect it more effectively. So there's a lot of reasons why you would want to obfuscate. And a lot of things can happen in here. You can rename your functions. There's like application packing. You have things that you can do with control flow to make it more complicated. Dummy code, which is something that a lot of people don't want to do as an engineer because it makes their code bases more complicated. But from a reverse engineering standpoint, it can add a lot of complexity. Encryption is a big one. A lot of malware you'll see with the huge encrypted blocks so that AV can't read it or defenders can't read it without decrypting it first. But a lot of this is just to evade other people from reading it. And there's a lot of reasons to do it on both sides. It's not just something that threat actors are getting good at. On the other side of it, you have things like reverse engineering. And this is another topic that you can have from both sides. Attackers want to reverse engineer software so they can find vulnerabilities, or they can find what an application is doing. An engineer might use it to uncover some other group's IP, or figure out if another company has stolen their IP. A lot of people will go through reverse engineering just to try to figure out if a competitor has stolen their own. And this can play a big role in like IP cases if you go to court for IP theft. Exploit development, a lot of reverse engineering. Sometimes you mess up and you just have to recover source code. If you had a binary that was like a legacy application and now you need to fix it, you can reverse engineer it, get some level of it back, patch it, and then move forward. And sometimes we just reverse engineer things to validate our security. Sometimes we go through a build process and we're promised all of these things, like your secrets are safe, and we go through and reverse engineer it, and we find things that shouldn't be shipped to a customer or publicly. So lots of reasons. And it's another one that typically will sit on the offensive side of the spectrum, where you're not really exposed to this until it's too late. But developers can benefit a lot from it, even if it's just to learn technologies better. To reverse engineer or to obfuscate something typically requires a level of knowledge of that programming language or that system, and it can be a great exercise to really test whether or not you really understand the fundamentals of that language. Like this is an example of Hello World written in Python. It's an absolute disaster. Most people would have no idea what this does. So it can get pretty complicated. But to do something like this, you really have to understand the intricacies of Python. You start swapping things out for different feature sets that may not be well known or well used, and you can make this, you can make it happen. There's actually competitions for code obfuscation, how complicated you can get something or how little you can get a binary. And some of those people who are doing these exercises are incredibly talented in that language because they've gone so far into figuring out the intricacies so that they can do this kind of development. So we've gone over a lot of these different layers. There's a lot of different pieces to each layer. There's a lot of ways you can approach it. There's a lot of deviations between how an engineer might look at a layer versus like a cybersecurity professional. And this is continually getting more and more complicated. I still personally think that having some level of exposure to all of this is kind of very important for a cybersecurity professional, because not only are you trying to defend against full systems typically, but like an attacker, like a pen tester or a red teamer is going to be touching every layer of this. So sometimes it can be very important to know how everything fits together, or how your attack may impact a service at a different layer. If you don't understand it, you can get into a lot of trouble where you start crossing lines in scope and causing issues that you may not have expected just because you're not familiar with a specific technology. But it's important to note you don't have to be an expert in every layer. I just think it's very helpful to be familiar with it, or at least know how it sits in the full stack. And I tell a lot of people a really good way of kind of testing your skill set and figuring out where your weaknesses are is to go through and deploy an application that touches all of these layers. So it may be as simple as like deploying a web application in AWS where you're touching cloud infrastructure, you're touching networking because it has to be exposed publicly. You have an application that's serving some sort of content. Maybe you have logging so that you can see what the requests are coming in. You throw some sort of process in front of it. You have some sort of secret management or Git process to manage your code base. Maybe it's being deployed through automation. You can start taking each of these layers and apply them to a very simple project like a Hello World website and get exposure to every single layer. And it's not as simple as it may seem, and as you start, you realize that there's a rabbit hole where you can go through and you can start adding, testing processes in your deployment scripts, or how it's being monitored, how things are like security features that are built into your web application, how your code's managed, where your certs are being managed. So there's a lot of pieces that as you start to develop this test environment, you can say like, oh yeah, that's something that I didn't expect to happen. And then you can flip it to the other side and start attacking it. You start realizing where you messed up when you start building these complex systems. So, in closing, as a summary, a full stack mindset can be great for both sides, both engineers, even if you don't touch with it or deal with that layer in your professional career, it can be really good to know how it fits into the system. From an attacker, it can be great because you're going to typically be attacking a full system, not just a single layer. A lot of hackers are going to interact with the full stack regardless of whether or not they want to or not. Both hackers and devs, developers or engineers, can learn from each other. I think this is something that we should do more of in the future, which is take development tools and move them into cybersecurity and vice versa. I think the more the two are familiar with each other's disciplines, the better off we are. And a lot of times an engineer will have a completely different approach to a system or to development than a hacker will. I think it's important to realize that, especially as we're pushing other people into the careers or into this field. We're all going to have different paths into this industry, and it could be through any of these individual layers. And yeah, the more you understand how things connect, the better attacker you're going to be. So that's the full stack for hackers. Like I said, it was more of a discussion. It kind of jumps around a lot because I find a lot of it interesting. But do we have any questions in the last couple minutes? Sweet. I can't really see anyone anyways. That's great. Cool. Well, thank you very much. Oh, he put his hand down? Yeah. I'll just tell you later. It's a programming interface, application programming interface. It's how you interact with a service. Cool. Thank you very much.